Welcome back to part 2 of section 3.2. We're going to be talking about graphing these functions. So we're going to graph 2 to the x and log base 2 of x on the same coordinate plane. So for 2 to the x, make a quick table, -2, -1, 0, 1, 2. So we're going to be at 1/4, 1/2, 1, 2, 4. For 3, we're at 8. So for that, there's a horizontal asymptote. So I'm not going to draw it, but we're going to keep that in mind as we sketch the graph. So there is f of x. Now, for g to the x, that's y equals the log base 2 of x. Remember, your calculator doesn't really do log base 2. So what we're going to do is we're going to take it first from this logarithmic form to exponential form. So we do that, we do 2 to the y equals x. Now, when we graph this, our input is still x. Our input is going to be the exponent. Now, our inputs this time are going to be our y coordinates. So we're not going to put in our values for x, we're going to put our values in for y. So 2 to the negative second is 1/4, 2 to the negative first is 1/2, 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, and if we put a 3 there, 2 to the third is 8. So our points now are going to be 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. Now this has a vertical asymptote at x equals 0. So when we sketch that, we want to make sure we don't cross that vertical asymptote. And there's g of x. Now you can see, if we draw a line y equals x, they're reflections of each other. These are inverses. They're inverses of each other. Now let's sketch problem number 28. So f of x, or y, equals the log base 10 of x, or the log of x. So we're going to rewrite it into exponential form. 10 to the y equals x. And we're going to graph this by putting our values in, not for x again, but for y. -2, -1, 0, 1, and 2. That's one of the rules when we're graphing logs, is we put our inputs in for y after we write it in exponential form. So we have 1 over 100, 1 over 10, 1, 10, 100. So we're at 1 over 100, we're at -2, so right there, 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 and there. Once again, there's a vertical asymptote at x equals 0. Logs have vertical asymptotes. And then our graph is going to look like this. So we have a vertical asymptote at x equals 0. Our domain now is going from 0 to infinity with parentheses at both. We never get to x equals 0. Our range this time is all real numbers, so -infinity to infinity. And we can find our x-intercept this time is at 1, 0, and our y-intercept, we never cross the y-axis, so there is none. And that's graphing y equals log of x. So for the characteristics of these log graphs, so if I graph just y equals the log base 8, let's just do log base 3 of x. So what we do first is we do x equals a to the y. So we would rewrite this 3 to the y equals x and make a table of values. negative 2 for y, negative 1, 0, 1, and 2. So we have 1/9, 1/3, 1, 3, and 9. So we're at 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, 9, 2. And our vertical asymptote, x equals 0. And here is our graph. And that's what the basic shape of these log graphs look like. So the domain is going from 0 to infinity. Our range is all real numbers, negative infinity to positive infinity. Our intercept, our x-intercept is at 1, 0. Our y-intercept, there is none for this one. Don't worry about the behavior, the vertical asymptote, x equals 0, and don't worry about the intersection or the reflection or anything like that. So there are some characteristics that are important to know. Don't worry about behavior, intersection, intervals, or reflection. So we're going to sketch this. Now, we have some transformations occurring. So we're going to graph the parent function first. Y equals the log base 3 of x. So luckily enough, we just did that. So that's 3 to the y equals x. So I'm going to use the values I used before. 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, 9, 2. Now, my value for A is 1, so nothing happens there. H is 1, and K is 2. So we're going to go to the right 1 and up 2, just like we've been doing before. Go to the right 1 and up 2. Go to the right 1, up 2. To the right 1, up 2. Right 1, up 2. Right 1, up 2. Now, not only did all of our points move to the right 1 and up 2, but our vertical asymptote moved to the right 1. So we're at x equals 1. So there is our graph after we transformed it. So our domain is going from now 1 to infinity with parentheses. Our range, still all real numbers, negative infinity to positive infinity. Our vertical asymptote is now at x equals 1. Our x-intercept is at 1 and 1/9, 0. And our y-intercept doesn't exist. It's at none. There is no y-intercept. We'll be working with those x-intercepts. Don't worry about them yet. Number 30 is a more challenging problem. Y equals the log base 4 of x. So that means it's going to be 4 to the y equals x. And we're still substituting our values in for y. Negative 2, negative 1, 0, 1, and 2. 4 to the negative second is 1/16. 4 to the negative first. Actually, excuse me, real quick. That's not 1 and 1/9. It's 1 and 1/3. Where's the x-intercept? 1 and 1/3, not 1 and 1/9. So we're at 1/4, negative 1, 1, 0, 4, 1, 16, 2. So then A is negative 1, H is negative 3, and K is 0. So for our transformations, we have an x-axis reflection. We also have a shift left 3. And then K is 0, so nothing happens there. So we have to take care of our reflections first. An x-axis reflection. So we're at, change those y values. So now we're going to be at 1/16, positive 2. 1/4, positive 1. 1, 0. And then we're at 4, negative 1. And now we're going to shift everything to the left 3. Go over to the left 3, to the left 3, to the left 3, and to the left 3. Now, not only did we move all of our points to the left 3, we also moved our vertical asymptote as well to x equals -3. And there's our graph. So our domain is going to be at from -3 with a parentheses to infinity. Our range goes from -infinity to positive infinity. Our vertical asymptote is at x equals -3. Our x-intercept we can actually see is going to be at, I'm not even going to worry about the intercept because there's actually an x and a y-intercept. This is a little bit trickier to find. We'll work on solving for those later on, but we'll save that till later on. On the next page, you can graph these on your calculators. Now, the key to remember is that we can't take the natural log of a negative or 0. So what we're going to do is we're going to set x minus 3 greater than 0, add 3 to both sides, x is greater than 3. And if you were to graph this on your calculator, you'll find that your graph looks like this. So our domain is going to go from 3 with a parentheses to infinity. That's the domain of that function. For the next one, once again, you can use your calculators to graph it, but when you do that, you'll notice that you can't take the natural log of a negative number or 0. So 3 minus x has to be greater than 0. So I can add x to both sides. 3 is greater than x. And when I rewrite that, so the variable is first, x is less than 3. So that would be what we would use for our domain. Or if you looked at the graph, you'll see that we're at 3, but that's the asymptote, excuse me. You'll see that the graph looks like that. You see how it's going to the left? The domain, as we found algebraically, it's going from negative infinity to positive 3 is where it stops. And for the next one, whenever we're squaring a number, whether it's a positive or a negative, when you square a number, it's always going to be a positive. So here what we have is x squared equals 0. We're going to find out the only thing we can't have is this. So when we take the square root of both sides, x equals 0. That's the only thing we're not allowed to have. Algebraically, that's our domain. That's what we can't have is the 0. If you look at the graph, you'll see it looks like this on the left, and on the right, it looks like that. So the only thing we have is that asymptote at x equals 0. So our domain would go from negative infinity to 0 with parentheses at both, and the union of 0 to infinity. There's our domain. You can see it algebraically, and you can also see it using the graphs. And then to finish up, just some uses of it. You can use it as a model. There's logarithmic models. There's natural log models. So all we're doing is we're just evaluating this function at the given points. So when t is 0, so f of 0 is 75 minus 6 times the natural log of 0 plus 1. So it's 75 minus the 6 times the natural log of 1. And you can just type that in. You'll find that f of 0 equals 75. So that would be the average score of the exam at 0 months. Average score at the end of 2 months. So f of 2 equals 75 minus 6 times the natural log of 2 plus 1. So it's 75 minus 6 times the natural log of 3. And just a calculator question, f of 2 equals 68.408. And then finally, 6 months. f of 6 equals 75 minus 6 times the natural log of 6 plus 1. F of 6 equals 75 minus 6 times the natural log of 7. And that would be 63.325. And what that's just showing is that after you take a test, it's more likely you're going to be forgetting that information as time goes on. Okay, thank you for your time. I will see you in the next